Thank you for taking this survey. In this short video, we are going to talk about an approach to develop energy efficient and cloud connected applications. This is the work we have done in the Software Engineering Research Lab at DICT, and we believe that this approach is useful and applicable in the real world. Hence, we want to take this survey and solicit your advice and opinion on this approach. The apps that can benefit from this approach are basically UI heavy applications that are connected to cloud and they run on the battery operated devices like smartphones, tablets, and smart devices like watches. Um, the goal of all the developers that have built applications for battery operated devices is to make sure their application consume the least possible battery. In such devices, generally a paradigm called model view model is used, MVVM, where the views are the user interface pages that are shown to the user, and the data that is shown in those views is captured in objects called view models. So these view model objects are like one to one for each view, and they are connected to their views using the data bindings. Basically, the objective of having data binding is that the any change in view model state, any data update automatically gets reflected into in the view, and any input from the view automatically gets updated in the view model. In addition to view and view models, we have data models, which are much larger objects. They could be collections also. There could be multiple data models from where the view models get their data. So view models do the processing of these data models in terms of filtering or sorting or searching to extract the data that matches what is required on the UI. So we have also found that in most cases, the data that is lying on the data model is never used fully in the view. So it is just lying around there. So that is the data that is gotten from the API calls from the backend service, and it is dumped in the data model. So the processing, therefore, of filtering, sorting, searching, etc., and storing the data in the data model objects happen on the client side. That processing consumes a lot of battery. So our new approach called RMVRVM, remote model view, remote view model, is an evolution of the MVVM approach. So in this approach, our focus or goal is that there should be no processing of data on the client side, and there should be no data on the client side which is not useful, no excess data on the client side. So in that case, we have the views as it was in MVVM, but the view model objects are also there, but we call them view model proxy objects because the real view model objects are lying on the server side actually. So the server side has the view models corresponding to each view. The remote model objects that we had in the MVVM on the client side, they are also now on the server side in RMVRVM. All the processing conversion is done on the server side, and the API is sending the response in JSON. That is a view, the data required by view. That response is received on the client side, and the JSON, there could be a JSON to the VM mapper. If the, let's say the technology stack is a little different than JSON, but if it is a JavaScript based thing, then JSON can be directly the view model data object. So the VM here, the view model here is just acting as a proxy of the view model on the server side, and it gets the data into the view, and through the data binding, the user interface works well. So this is the architecture which makes basically transfers the processing of data on the server side. And to emphasize once more, The advantage of RMVRVM is that we no longer have any processing of data on the client side. We no longer have any excess data on the client side. All the data that gets into the server client side from the server is 100% usable data. So we conducted experiments as well as case studies on open source and real world applications to um, measure or know the efficacy of the proposed paradigm. We developed an application, experimental application, where you could run it in mode of RMVRVM or regular mode, where if you run it in RMVRVM, it will execute the tasks on the server side, bring back the results, and then display it here. So we have seen that this blue line indicates the battery consumption on the devices, which when used in the MVVM mode, and orange and gray line indicate when used in the RMVRVM mode. Orange line is for the when the Wi-Fi was used for the internet connection, and gray line is when the 4G is used. So we can see a substantial um lesser consumption of battery in both cases of RMVRVM as compared to the blue line, which is the MVVM case. So all four devices resulted in much lesser Wi-Fi battery consumption. We also picked up an open source application and the story was same. The blue line indicates the battery consumption on the with the MVVM paradigm. We migrated this application from MVVM to RMVRVM. So we conducted the experiment for MVVM and then the RMVRVM, and there is a substantial reduction in the battery consumption, up to 42%. Additionally, because of no extra data coming into play on the client side, because of no processing on the client side, the response time of the application has improved a lot by 45%. We have also come up with the extensive guidance on how we can adopt this RMVRVM framework. For example, there is a clear set of architectural changes that are required. This migration framework is also provided. We also understand that many applications may have hundreds of pages also where MVVM design pattern is applied. So moving them all together to RMVRVM may not be possible. So phase-wise migration is also possible. We also have studied that client-side and server-side caching could be done wherever the data is frequently used and we don't want to get to server again and again to get the same data. So caching is all okay for RMVRVM paradigm. So in addition to this, we have done a lot of research on the server-side energy consumption, on the client-side energy consumption, and much more detailed research work is available. If you are interested, we can share with you the research work. And our overall goal is to have this paradigm plus the server-side techniques save net energy also. Right now, it might look like we are just transferring the processing on the server side, but experiments and research work that we have done indicates that on the server side, it that there is net save of energy possible. As usual, um, with any approach, this paradigm also is not applicable for some category of applications. For example, the ones that are not connected to the internet, like standalone games or applications. Um, some application which have high degree of offline functionality may not be, suitable for applying this paradigm. Some of the application may have a very simple UI, but their battery consumption is primarily due to other factors. For example, through speakers or a network or something else. Then the gain of applying RMVRVM may not be that much. Some applications which are connected to internet but are using only third-party APIs may not be possible for them to use this paradigm unless they can create their backend server, backend layer, which where RMV, RVM is applied, but and that layer talks to the third-party application. So it is possible, but it without not without having their own uh, backend system. Thank you for taking this survey. There are going to be few questions that will follow. We urge you to answer them, write your opinion, and solicit your advice. How much this new paradigm you think could be applicable in your scenario, in your application that you're working on. We will also provide the APK of the experimental app that you can install on your device and see for yourself the difference between the both paradigms. You can reach us at this email also, and we really appreciate you sparing your valuable time for the survey. Thank you so much.